talking the light-dependent reaction, or the LDR, which happens in the chloroplast. We're talking thylakoid and stroma, and it starts with light.
So I am light and I give energy to the photosystem 2.
I'm photosystem 2. I absorb the light through chlorophyll and I oxidize this water, separating the electrons, creating high energy electrons, and I pass them down.
I am the cytochrome, and I take these high energy electrons and I use them to protein pump this through and then pass the lower energy electrons.
So I am light and I give energy to cytosystem 1.
So I absorb this light through the chlorophyll and then they become high energy electrons and then I pass them. I'm NADP reductase and I reduce the electrons onto the NADPH, which attracts a proton and makes it NADPH, which is an electron carrier.
I am ATP synthase, and this is an ADP. And right now the protons are at a concentration gradient, so I diffuse protons through to make equilibrium, and then this phosphates on to make ATP.
So our final products, when we're all said and done, are some ATP, an electron carrier called NADPH, and then don't forget, we still have that oxygen. We are talking about photosynthesis. Part 1 is the light-dependent reaction, or the LDR, and it happens in the chloroplast with the thylakoid and the stroma, and it starts with light.
Okay, I am light, so I give photosystem 2 a light.
I'm photosystem 2, and by using the chlorophyll, I can oxidize these electrons and protons off of the oxygen, and then I can pass them via high energy electrons.
And I have cytochrome complex and I use these electrons' energy to pump a proton, and now they are low energy because of doing that, and I pass them on.
And I am light 2 and I give light to that.
And I am photosystem 1, and absorbing light through chlorophyll, I can turn these into high energy electrons and pass them.
And then this is NADP+, and it can reduce electrons onto it, which will then attract a proton, making NADPH, which is an electron carrier, which will be used in step 2, the Calvin cycle.
And this is the ATP synthase. It diffuses the protons over to equilibrium and uses that energy to phosphorylate the phosphate onto the ATP.
So when we're all said and done, we have our NADPH electron carrier, our ATP, and oxygen. We are talking photosynthesis, and this is step 1, which is called the light-dependent reaction, which happens in the chloroplast with the thylakoid and the stroma.
I am light and I energize photosystem 2.
I'm photosystem 2, and I use the chloroplast to oxidize the electrons off of H2O and then pass them.
I'm cytochrome, and I pump a proton, and then the low energy electrons get passed.
I'm photosystem 1, and I absorb light through the chloroplasm and make them high electrons.
I am NADP reactase, and I add them to the NADP, which gets the proton, and that makes NADPH, and that's an electron carrier and will be used in step 2, the Calvin cycle.
And I'm ATP synthase, and right now we're at a concentration gradient, so 2 protons are diffused so we can reach equilibrium. And this is ADP, which then can be phosphorylized into ATP.
So when we're all said and done, we end up with some ATP, NADPH electron carrier, and oxygen.